of time. So we're getting some work time. It's not gonna be as short as you think, probably. All right. So when we're talking about fractions, complex fractions, to be specific, right? That means there's some sort of imaginary number in my complex fraction. Now, anytime I'm trying to write an answer with a complex number in it, we said it has to be in standard form, a plus bi, right? The real part's got to come first. We talked about that already. But if it's ever a fraction, we want to rationalize it, which means we're going to take and make sure there are no i's in our denominator. Right? Imaginary numbers in your denominator are not a good thing. So when we write our final answers, we need to make sure there's not an imaginary number in it. So we call that rationalizing. So if it ever says on a test or on the homework, rationalize, it means get rid of all your i's in your denominator. Alright? So, to do that, we're going to multiply top and bottom by the conjugate of the denominator. Why do you think we would do that? What has happened every single time we multiplied a complex number by its conjugate? What have we gotten rid of? The i's, right? So if I multiply the denominator by its conjugate, I should have no more i's in my denominator. Right? That's the whole idea of this, is to get rid of the i's. So that's why we're multiplying by the conjugate. So the first one, 1 over 2 minus 5i. Well, if my complex number is 2 minus 5i, what would its conjugate be? 2 plus 5i. So I'm multiplying both top and bottom by the conjugate of the bottom. So remember, whenever I have a fraction, what I do to the denominator or the numerator, I have to do the opposite. What I do to the top, I have to do to the bottom, and vice versa. So I'm multiplying here. Right? If you need to write it out as one big fraction, go ahead and do it. 1 times 2 plus 5i over 2 minus 5i times 2 plus 5i. If you need to do that, go ahead and do it. 99% of the time on the problems we do, I will not write it out like this. I'm just going to start my multiplication from up top. Okay? But if you need to, write that out. So on the top, what do I do with that 1? I mean, technically you distribute it, but you can just get rid of it because 1 times anything is itself. So 1 times 2 is 2. 1 times 5i is 5i. Over. How do I multiply that bottom? FOIL. Oh, 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is minus 10i. Negative 5i times 5i is minus 25i squared. Alright, so we're good so far. Right? Do we all follow what I've done so far? Okay, now the whole point was to get rid of my i's. So when I combine my like terms, 10i minus 10i cancels. Two plus 5i. Over 4. What is this I squared? What happens with that? It turns to negative 1, right? Anytime I have I squared, I'm changing it to negative 1. Now I'm going to skip the step of writing that whole part out. Negative 25 times negative 1 is what? Positive 25. So 2 plus 5i over 29. Now, right? We all follow that? Okay, that is not your final answer yet. We are super close. When we write in standard form, we have a real part and an imaginary part, correct? Do we all agree? Okay. Do I have that right now? No, it's one big fraction right now, right? So what we need to do is we need to separate it into a real part and an imaginary part. Now how we do that is we take 2 over 29 plus 5 over 29. Or you can put 5i over 29. Either one works. All I'm doing is I'm splitting it. Real and imaginary. Because then what I can do, if I have the ability to, is reduce those fractions. Now in this case I can't reduce any fractions, but if I could, you need to do that. Does that make sense? Right? It gives us a real plus an imaginary part like we want. And that's our final answer. Like I said, if you want to write 5I over 29, that's also acceptable. It's perfectly fine. Okay, any questions on that first one? That one took on a little bit, didn't it? I'm going to go a little bit quicker with the second one, okay? Please stop me if I'm going too fast. 3I over 5 minus 2I. Same thing, I want to get rid of that I in my denominator, so I multiply by the conjugate. Well, the conjugate of 5 minus 2I is 5 plus 2I. Right? Switch the imaginary sign. Well, on top here, I'm going to distribute 3I to both of those pieces. 3I times 5 is 15I. 3I times 2I is plus 6I squared. Yes, sir?
Whatever you do to the top, you have to do the bottom.
Correct. So if I multiply by 5 plus 2I on top, I got to multiply the same thing on the bottom. Vice versa. On the bottom, I'm foiling. 5 times 5 is 25. 5 times 2I is 10I. Negative 2I times 5 is minus 10I. Negative 2I times positive 2I is minus 4I squared. Alright? Do we all follow me so far? Okay. When I combine like terms, 10I, negative 10I cancel. I change all of my I squares. I have one in my numerator and one in my denominator. They get changed to a negative 1. Now, like I said, I'm not going to write that step out just to save some time. But I get 15I. 6 times negative 1 will give me negative 6. So I get 15I minus 6. Over 25. Negative 4 times negative 1 is positive 4. Right? Will you all still follow me?
Yeah.
Okay. What?
Oh, no.
You good? Okay. This becomes negative 6 plus 15I. All I did was I switched their order. So I want the real one to come first. Over 29. And then my last step, separate them into a real part and an imaginary part. Negative 6 over 29 plus 15I over 29. Right? I cannot reduce my fractions at all, so that's my final answer. Now, like I said, if you want to write it how you did in the first one, or you put 15 over 29, you put I out here, that is also okay.
Doesn't matter which one you put, like, doesn't matter what order you put in it.
Yes, so you still need to put that real part first. So negative 6 over 29 still needs to come first. Okay? Just like you did with the other ones. Real plus imaginary. Okay? Cool? We got 2 down. We have 4 to go. Okay. We'll do the third one together, then I want you to do the fourth one on your own. Third one. 2 minus 3I over 4 minus 3I. Multiplying top and bottom by what? The conjugate of the denominator, right? So the denominator's conjugate will be 4 plus 3I. I am multiplying top and bottom by that. Do not take the conjugate of the numerator and multiply by the numerator. Only the conjugate of the denominator are we multiplying here. So, on both top and bottom, I'm going to end up foiling. Right? On top, I get 2 times 4 is 8. 2 times 3I is 6I. Negative 3I times 4 is minus 12I. Excuse me. Negative 3I times positive 3I is minus 9I squared. Over 4 times 4 is 16. 4 times 3I is 12I. Negative 3I times 4 is minus 12I. Negative 3I times positive 3I is minus 9I squared. All I did was FOIL, top and bottom. Okay? So now you go and you combine your like terms. 8, 6i minus 12i is going to be minus 6i. Negative 9 times negative 1 is going to be positive 9. Over 16. 12i minus 12i cancel. Same thing, negative 9 times negative 1 is positive 9. Any I squared becomes a negative 1. So in this case, I get 17 minus 6i over 25. And all I gotta do then is split it. 17 over 25 minus 6i over 25. And that's our final answer. Alright, we're multiplying top and bottom by the conjugate. Any questions on that? I know I went pretty quickly. But like I said, I want to make sure we get a bunch of work time. So, any questions on that third problem? We good? Okay, then I want you to try that fourth one. If you have a question, raise your hand. I'll be more than happy to come help you. Alright? We'll go through it in, let's say, like a minute and a half to 2 minutes. Other than that, get to work. Do it. Wash your hands in the bathroom.
It's just I by itself, and you do when it's I squared and you break it down. Does it turn into like
So which one?
this one? It's I squared and
Mhm.
49 by itself, so if you want just
Yeah, so I squared still turns into negative 1.
so
Wait, so if the I is negative, like if the I is by itself, it's negative.
What's that, sorry?
Why is it negative?
So, this?
It says negative. Or I squared always turns into negative 1. But if I do minus the negative 1, right? Then why is it positive?
So, I think we're talking about the same thing.
Yeah.
This, right, this part here can mean negative 1. But minus the negative 1 turns into positive 1. So that's what I've been trying to say.
Oh,
We're trying to say
yeah,
that.
okay, yeah.
So we're talking about the same thing. Yeah. So it turns into
Okay, sure.
Yes?
very well.
Oh, just the E.
Oh, yeah. 49 times. We should 49 minus negative 1, right? So just make change everything.
Just the E. I have another question. So then if you put the I to the side, does that technically mean it's only on
Nope, if this was in parentheses, you put it to the side, then it would go to both. But because it's right next to it, it just means these two are multiplying. Answer.
You wake up.
Minus negative.
Before you wake up.
How you doing?
I already had this question. I think I got that one wrong. I don't know what the difference is.
How'd you do this one?
This one?
Good?
Yeah. I got 19/48 plus 59.
How do you get that? Okay, I times negative I would be.
Negative I squared.
So I think most of this stuff's good. So be positive.
This will be 50.
Unfreeze it.
Shouldn't it be negative one?
Oh.
But remember, minus a negative one. Oh.
It's okay.
Guys, if you haven't done so already, please check your work against mine.
No, we got
Let me know if you have any questions. I know a big question, I know Jay just asked it, I had a couple other people ask it too. This I squared turns into a negative 1, but minus a negative 1 turns into a positive 1. Alright, so that was kind of the big mistake I saw. Like I said, double check your work quick. Right, let me know if you have any questions. All I did, I foiled top and bottom. I combined all my like terms. Changed all my I squareds to negative 1. And I combined my like terms again. And I split up into a real and imaginary. Yes, sir?
Wait, so how is it minus instead of adding?
Here?
Yeah.
Both of them, you mean?
Yeah.
So because this is minus 67, you could put plus negative 67i if you wanted. But yeah, since it's subtraction here, that's why it's minus. Okay? Any other questions? Anything at all throughout that whole process? It's a lot of stuff. Nothing? We're all good?
Yeah.
Okay, we got 2 problems to do. These ones will be quicker. I promise. Am I good? Can I keep going? Everyone's got it written down? Okay. 6 over I. So, still multiplying by the conjugate of the denominator. What is the conjugate of my denominator? It'd be negative I. Right? If this is positive I, my conjugate is negative I because I'm switching the sign of the imaginary part. If you need to, take your denominator. Alright, if I write it with the real part, it'd be 0 plus I. Which means my conjugate would be 0 minus I or negative I. If you need to do that, write it off to the side and then figure it out. When I multiply these things, 6 times negative I is negative 6I over I times negative I, which is negative I squared. Okay, I squared turns into what? The bottom will turn into positive 1, but I squared turns into negative 1, right? Negative 6I over minus negative 1, or negative negative 1, turns into negative 6I over 1. Which, could you leave your answer like that? Yeah, I'm okay with that. That's fine with me. Now, a better answer would be just negative 6I. Like I said, technically be simplified.
Oh yeah.
If you also wrote 0 minus 6i, that would be acceptable as well, because that's just putting a real part out in front. There's some not. I'm going crazy. Sorry. Any questions on that one? That one was pretty easy. Anything? Okay, one more. 8 over negative 11i. My denominator is negative 11i. I need to multiply by its conjugate, which would be positive 11i. 8 times 11i will give me 88i. Over negative 11i times 11i, negative 121i squared. Well, I squared turns into negative 1. Negative 121 times negative 1, give me a positive, so 88i over positive 121. Now, is that my answer?
Wait,
I liked your first answer.
I don't know.
No, why not? Someone tell me why not. I can simplify my fraction, right? Remember that first problem I said, if you can simplify your fraction, you need to do it. Now, what can I take out of both 88 and 121?
11.
11. So if I do 88 divided by 11, I get 8i. 121 divided by 11 would be 11. So I get 8i over 11. Once again, if you want to put 0 plus 8i over 11, I'm perfectly okay with that as well. Any questions? We only have one more day of new learning. Because then Wednesday is our review, and Thursday will be our test. It's a short unit. Alright? Cool. Swipe up. Subscribe.